Hello everyone, I am Dr. Godanda Raman. In this section we are going to discuss with short question and answer unit 5 queuing theory operation research. See the problem. So define Kendall notation. Kendall notation is nothing but A, B, X, Y, Z. Sometimes some books is mentioned A, B, C, D, E. So for here this is a Kendall notation. So A arrival pattern, so inter arrival time. B service pattern, service time. C is nothing but number of server. So this is a single server or multiple server. And system capacity, this C and D. So here Y is the system capacity, finite and then infinite capacity. Then Q discipline, first come first serve or first in first out, last come first serve or last in first out, random selection service, priority. So the priority, primitive, non-primitive. So this is a Kendall notation. This explanation is not necessary. So just write Kendall notation means A, B, C, D, E or A, B, X, Y, Z. Just mention what is a A, inter arrival time, B, service time, X, number of server, Y, system capacity, Z, Q, discipline. It's enough for 2 mark. Define reneging. So customer may enter the queue but after some time lost patience and decide to leave. This type of customer is reneging customer. Define balking. If customer decide not to enter the queue upon arrival, he is said to have balking customer. The customer arriving for service, if the queue is long, the customer decide not to enter the queue. This type of customer, balking customer. Define jockeying. So jockeying customer is nothing but 2 or more parallel waiting line. So 2 or more parallel waiting line. So customer may switch from one to another. That is a jockey for position. For example, now to consider toll booth. So this is a 1, 2, 3 some consider toll booth. So when car arriving for this route, correct? Suppose this line is moving fast, then suddenly from this line car to switch to another line. So this is a jockeying type of customer. Define bulk arrival. So more than one arrival can be entering the system simultaneously. The input is said to occur in the bulk or batch. So more than one customer when arriving for service, 2 or more number of customer when arriving service. This is a batch arrival or bulk arrival. Define little formula. So little formula is nothing but the queuing theory answer 2 question I mentioned earlier. One is a number of customer, we use the letter L, and waiting time. So waiting time W. So average number of customer in the system Q, and waiting time system Q. So this is a LS, LQ, WS, WQ. So for this answer queuing theory. So this type of question to answer the queuing theory. If you know any one, all other 3 is easy to calculate using the little formula. So LS equal to lambda WS. For here WS equal to LS by lambda. and then LQ equal to lambda WQ, WQ equal to LQ by lambda, WS equal to WQ plus 1 by mu, LS equal to LQ plus lambda by mu. So this is our little formula. Now this little formula, if any one LS or LQ or WS or WQ, any one we know, all other three easily to calculate. So this is the only main purpose we are using little formula. So discuss the application area of queuing theory. The application is nothing but queuing theory is a powerful tool for modeling many practical application. Here some of the application is mentioned. Telecommunication, it's a network traffic. Banking and service center, so customer waiting time. When we are consider a banking or service center, any type of service center, to consider waiting time, customer waiting time. And the transportation system, so transportation is a traffic, so when the traffic jam happens, is a transportation system to follow. And manufacturing, so machines queue when product manufacture, any type of production to apply, so the product or whatever the process we are apply, machine queue. And hospital, the hospital is nothing but patients scheduling. So this is a following queuing theory applications. So many application is there. So here we have chosen some of the application. If you have familiar with some more application to specific to mention, because this is a two more, at least you give any two. For example, your experience point of view, so you have any application related to the queuing system to write here. So here some sample I give mention some of the application, so computer science related, so telecommunication, banking sector, and then transportation sector, manufacturing, production, hospital, this category is mentioned. So any type of application is possible. So write the formula for utilization factor for MM1 infinity first come first serve model. So MM1 is nothing but single server. So this is a single server and this is a infinite capacity. So utilization factor is nothing but using the notation rho. So rho is utilization factor is nothing but lambda by mu. So lambda arrival rate, mu service rate. So the formula is nothing but lambda by mu. Rho equal to lambda by mu is nothing but utilization factor. So this is the short question and answer for unit 5 queuing theory subject. Thank you.